In this video, I will show you why I use Lakehouses for my gold layer, but still write SQL queries for data transformations and for mappings. So, of course, if you're coming from a SQL world, you can do Fabric Warehouse and write T-SQL stored procedures for your data transformations. And if you do Lakehouses, you can write notebooks, and within notebooks, you can do PySpark, but you can also do SparkSQL. And today I'm going to show you how to do SparkSQL and what the differences are between queries that run SparkSQL and PySpark for that matter, and why I choose to write most of my notebooks using SparkSQL. So let's dive into my laptop and find out. Alright, so here we are looking at my notebook. It's called SQL versus Python, and I've created a very simple notebook structure in which we can map data or transform data into a delta table. So I have two variables that I defined here. One is a list of key columns. In this case, it's only one column name. It could be a list of multiple columns, of course. And then the table name, and this is the target table in which we are going to merge our data frame with the output of our data transformation. So this would usually be the target table in our gold layer, in our data warehouse, in whatever we call it, our dimensions and facts layer usually. For now, I've called this one Fact Taxi 2024. First of all, my preferred way to do data transformations, which is writing SQL. And the reason I'm writing SQL is I know SQL, and I've grown up with SQL basically since 2013. I've written almost exclusively SQL queries to do data transformations. So this is my preferred way to go, and personally I find this to be more readable, to be more easily digestible, and SQL is the main language of choice if you want to do set-based operations over data sets, which is what you're doing if you do data transformations, if you're doing mappings for a data warehouse layer. So, looking at a typical SQL query that you can write using SparkSQL inside of a Python notebook, or I should say a PySpark notebook in Microsoft Fabric. So our goal with this query is that we get a result set into a data frame. A data frame is a variable that can hold a temporary table, just like you would do this hash table or in-memory table, temporary table, whatever, in SQL Server. Usually you would write insert into hash and then table name. Here we would create a Spark data frame in order to hold that intermediate data. And we can do so by saying variable name equals spark.sql. And within spark.sql, you would put in a string that can be executed as a SparkSQL query. So that's what I've done here. I've put in the f here to be able to put an f string in. For now, I don't have any variables that I'm inserting into this table, but maybe I could. Maybe I want to say passenger count here equals 5, passenger count cut off, and then in this f, using f here, we can do variables. So here we can then say, wait a second, passenger count cut off. And now if we run a query, this part here will be changed to the value of our variable, and that's what the f string in Python here is doing. So that's actually quite cool that you can do that. You can do that with regular SQL, with SparkSQL at least. Also, I'm using 3 double quote characters in here to delimit my query, and 3 double quotes make sure that I can do multi-line strings basically in this function, in the spark.sql function. And from there you can write your regular SQL query. And now I am very nitpicky on using lowercase SQL. I see a lot of people and the documentation and everybody and their AIs and everything doing uppercase SQL. I find it to feel very shouty. I like my lowercase. It feels a little bit more mellow. Okay, so lowercase select, we select a bunch of fields from a table. I usually call my base table that I select from T. This is something I learned in my first job. Shout out to Renee. And what we are doing there is making it super easy to copy and paste joins. Why T? Because it stands for transaction if you're mapping a fact table, or because it stands for table. I don't care. We could have called it X or Z or Y or A or B. It doesn't matter. We've called it T for table. And this makes it easy to copy joins, because maybe I am writing mappings from other transactional tables than this one. And maybe I want to copy this join, and by calling every table T and not the abbreviation of the actual table that I'm referring to, I can simply copy and paste this join. Now for the other joins that I write, I usually write an alias that makes me understand what table it is I'm referring to. So for the base table I could simply call it T, but for my pickup locations I might call this PU, and for drop-off locations I might call this DO. Then of course I work with proper indentation. I do so for the select, I do so for the joins, and I do so for the where clause. And in the where clause, I'm doing this little where 1 equals 1 trick so that I can put all of my actual filters on the same level of indentation. And I can easily comment out the first or the last where clause filter without actually breaking up the syntax. So that is something that I like to do. And we end up with this very nicely formatted query that we can easily follow. We can see what it does, and we can figure out where I'm reading from, what the joins are, what the filters are, and what the mapping definitions are. So here I see this blue S, that means that I'm renaming a column. Here I can see that I'm doing multiplication and a division operations. I'm filtering for where the pickup and drop-off burrows are not the same, so I can easily see that I am now filtering only for writes that happen outside of my burrow, or actually that happen to another burrow. So I'm writing this SQL query because I very much prefer SQL. I can write it with my eyes closed. I can just put it in there. Also, it is very readable, I think, and if you are manipulating large sets of data, SQL should be the way to go. Now, the reason I'm not doing this in Fabric Warehouse stored procedures, but rather in PySpark notebooks with Fabric Lakehouse, is the following. I can work with my Spark data frame and I can do things like a Python merge operation. And I think I've spoken about Python merge before, but for the people that are not familiar with that, I end up with this variable called df with SQL. It's a variable of the type data frame, Spark data frame in this case, and I can do things like this. I can put my delta table into a variable object. I can put in a merge condition, which is very cool. You can do this string join or text join. I always forget what it's actually called. And you can then do this very easy 5 or 6 line Python merge operation, where in SQL this merge operation might have taken many lines, depending on are we inserting, updating, deleting, how many fields, what is the business key, and so on. This makes it very easy to do this super sleek Python merge. So it's not that I prefer SQL over Python all the time. I prefer SQL for data transformations. I prefer Python for things like this, for doing merge operations, to make my life super easy. And here basically we're saying we want to have our target table, which is a delta table. I alias it as target, and I want to operate with a merge statement. In that merge statement, I have a source data set. It is my data frame with SQL, df with SQL, and I put it on an alias called source. This is usually what I do, because then in here we can do target.key and source.key for every key in key columns. Remember the key columns we have here. This will work if we have multiple entries in the list. It will create A equals B and C equals D and so on and so on and so on. Then the condition that we are going to merge on is our merge condition. That is this string that we create here in the merge condition variable. And then we simply say when matched, update, when not matched, insert and execute. This is it. Python merge is the bomb. You should use it. This is something you cannot use in Fabric Data Warehouse because you have to write T-SQL, and you can do a T-SQL merge as of lately. That's perfect. That's cool. But this is incredible. I really like how this merge is set up. So we're writing a SQL query here into a Spark data frame, which is a Python object, a Python variable, and then we're throwing that into a Python merge. Now, of course, you can do the exact same query in Python, and then that would look like this. So here, I would be creating multiple lines, basically, just like my SQL query, where I say I have a base table, spark.table, and then I refer to by table name, and I join on 2 different tables, my pickup location and drop-off location. I do .join from pickup to my column pickup location ID equals location ID, and I do a left join. Now do the same thing for the drop-off locations. Then I apply a filter, and here you can see that we apply 2 filters with an AND statement, because we do filter 1 and filter 2, where the burrows should not match and where the passenger count should be larger than 0. Now we have our base data set all put together, basically. So we've read our base tables, did the joins, then did the filtering, and now we are going to select the columns that we need. and we're writing f.col blah blah blah. For all the columns where we do an alias, we will write .alias and then the name that we are going to give to this column. If we do not put .alias, we will simply reuse the name that the original column has. And from here we can do the multiplication and the division operations quite easily. Now, I don't like this syntax. It's simply, maybe it's just a preference, maybe SQL is more readable, but I don't really like this syntax. There's a lot of f.col because I'm using the PySparkSQL functions as f. I have to tell the engine that everything that I'm doing here is a column, whereas in SQL that's implied, that should be understood by the engine and by developers. So I don't really like this. It is maybe a more verbose way of writing queries. That might be good, it might be bad. It's not my preference. There is one thing, however, that I really, really like, and that is the order of operations. And this is a topic that pops up on LinkedIn and on Stack Overflow and so on every once in a while, is the order of operations in a SQL query. It is all wrong. So when I write a SQL query, I first have to start selecting columns. I don't know what table I'm reading from, but I have to define the columns already. Only then I will know the table that I'm reading from. So that is a bit difficult to do. That's the only thing that I like here in PySpark, is that we start with our base table, then do the joins, then do the filtering. If we want to do filtering on the base table, we can up this filter a little bit above to make sure that the filter hits our table first, and then we only work with the filtered data. So that's actually really cool. And only when I've done all of that, when I've prepared my base data set, I start selecting columns. So that's something, the order of operations, that's something I like in PySpark. For all the other things, please, please, please just write a SQL query. You'll make me happy, and hopefully you'll make a lot of other people happy. Now, if you do not agree with me, let me know in the comments down below. If you do agree with me, let me know in the comments below. And in either case, give me a thumbs up on this video. And follow my channel, because every week I will be posting a video on Microsoft Fabric teaching you little things like this one. See you next week. Thank you.